Hi guys, this is a short video which is overview of book Think Python or Pink Titan, I don't know how do you prefer it, and I will review the first chapter of this book in this video. So you can find this book on this website here, I will put it in description below, and you can get this book from Amazon and you can download it as PDF or you can read it in HTML format on this website. You can find GitHub repository with many programs from this book written in Python 2, and you can find the content of this book on this website with chapters and subtitles in each chapter. And then we can start with the history of this book, which is a really interesting one. So this guy, Alan Doney, who wrote this book, is started in 99 when he was teaching students in Java, and he find that they learn not so well and they were frustrated at the end. The failure rate was really high, and the people even who were the best were with bad achievements, and he found that the reason was in the books because they were too complicated and with a steep learning curve, and they paid too much attention on the language itself and not on the programming, and the practical side of programming was neglected, and that's why he decided to write a book. He started with several rules. First rule is keep it short. Next one is be careful with the vocabulary. Build gradually the information and topics inside. And the last point, which is really important for me, is to focus on programming and not the programming language itself. So this one is really important for me because it's how to be a programmer and not how to be a Java programmer or how to be a Python programmer. First you need to know how to walk and then to run. And the initial title of this book was How to Think Like a Computer Scientist. And the interesting part was when another guy, Jeff Elner or Elkner, I don't know how to pronounce it, a high school teacher, translated this Java book into Python, and he sent a copy to Alan. And later Alan learned Python from his own book, which was translated by another guy. And this one it's really funny for me. And later the name of this book was changed to Think Python. And right now you are seeing this last version of this book. You can see some changes of this book here, and contributor list with acknowledgements. And let's move on chapter 1, which is the way of the program. So the first and the most important part of this book is to teach you how to think like a computer scientist, because there is a specific mindset of this computer scientist, which is including mathematics, engineering and natural science. You need to have the attitude for solving problems and the attitude for learning new things and to do many experiments with your programs. And the most important skill, according this guy Alan and according to many other people, it's problem solving. You need to define a problem, to think solution for this problem, to test this solution, and to prepare a product which is solving this solution for any specific case. And as we can see, this is a really difficult part. It's not learning the language, it's not learning the syntax or the methods, but learning how to think as a programmer is a really difficult job, and this is the one you have to be focused on and to pay the most attention. And let's move on Python. Maybe you know that Python is one of the programming languages which is really popular and very trending right now. Python is considered as high-level language. Another high-level languages are C, Java, JavaScript, C# and other like this one. And you have also low-level languages which can be named as assembly languages or machine languages. These are on a lower level, but they need more time, they need more code, and they're really more complex, and they're not for humans. Another benefit of high-level languages that they are portable, which means that you can run one program on several computers and the program is going to work in one and the same way. And this is not the same for low-level languages. Another interesting feature of Python is that it is interpreter languages, and you can see here how interpreter language is translated. So you have source code, then you have interpreter, and then you have output. So this is your source code, as you can see here. This is the program, and later we will have interpreter who is going to translate this program, and here we have the output of this program. And this is all about this picture here. On the other hand, you have languages like Java, where you have source code like this one, and you have compiler. This code is compiled to another object code and then is executed from another machine or program, and finally you have the output. So you have one extra step to this one, but you don't need to pay attention to this one right now. And another interesting feature is that you have interactive and script mode for Python. This is the interactive mode using Chevron and Python interpreter. So I will try to demonstrate it here. So this is Python console. You have Chevron here. So as you can see, here we have a simple Python code which is 1 minus 1, and we need to check the result, which is 0. And as you can see, we can write another program and we can see the output, which is 2. And this is interactive mode of Python, which is very useful for small pieces of code. But if you have a complex program, you have to use a script. And this here, it's a script which has many lines of code. And if you want to run code, you have to do it with command Python and the name of this file. Usually the Python files are ending with py at the end. So basically, what is program? A program is a sequence of instructions which is instructing your machine what to do and what result you expect at the end. So usually in a program you have input, output, some computations, conditional statements and repetition. For example, your input could be pictures, songs, texts or whatever else. Your output could be again text, images or video format, and computation is algorithm which is performing some steps on your data. For example, you can put image, you can classify this image, you can do some condition. For example, if this image is not not allowed for kids, it's adult content, and then repeat for another images, and finally output some classification for these images. This is all about programming. And there is another interesting part of programming which is named debugging. I don't know if you know, but bug is originating from the time when computers were bigger than your house, and at that time they found that one computer is returning a wrong result, and they start to analyze what was the real reason for this one, and they find that a little bug, I think butterfly or something like this, was the reason which entered in the computer, and it was giving shortcuts or problems with electricity in this computer. I forgot what was the name about this in English, but the idea was that this butterfly was causing a problem in a computer, and from this time it's used bug for errors in computer programs, and from there it's debugging, which means remove all bugs from your program and try to investigate where is the bug. So in general you have several types of errors or possible bugs in programming. The first one are syntax errors. Syntax errors means that your program is not correct and it's not compliant with expected format. Here we saw that this is a good format, and this is syntax error here. As you can see, we have red on this program, and as you can see, this program is not working fine. And for example, if you have this only, you have a syntax error which is saying that you have invalid syntax, and this is about syntax errors. You have runtime errors, for example, when your program is not giving error until you start your program, and when you start you can see an error. For example, if we have this program here, we will see error if we try to delete to 0. So right now this program is working fine, and if we try to divide to 0, as you can see we have a runtime error which is saying you have division by 0, which is not allowed in computing and also in math. And finally you have semantic errors, which are a type of errors when your program is working but the expected result is wrong. For example, in this program here I could expect max to be 10, but finally my program is working and I get 4. And this means that I have a syntax error here, so maybe if I change this to 11, max is going to be 10 at the end, and yes, as you can see here I have 10. So this is type of semantic errors, and you can do some debugging of your programs in order to be sure that your program is working. I will try to demonstrate what is debugging here. So first you need to put breakpoint. Here you can see how we can put breakpoint. By the way, this is PyCharm, which is a tool for writing and interpreting Python programs, or compiling Java programs if you use the brother of this program, IntelliJ, and let's start debugging of this program. No, debugging is this one. Here you have suggestions to install additional tool which is improving your debugging, so I will add it. And as you can see, right now we are in debug mode. We can see that we have one variable here which is named max and it's equal to 0, and we have another one which is hello world, and we can do some steps which the program is going to do one by one. And as you can see, right now we are here in this statement or this part of this program, and you can see that this variable here it's changing and the other variable it's changing as well, and this is debugging. And here we can see why this program is printing 3 at the end, because it's doing only steps from 0 to 3. But we will not pay attention to this one right now. And this is all about debugging. And you can see that even complex systems like Linux and Windows were started like small programs which were switching from A to B. You can find it here in this chapter as well. Here you have something to say about formal and natural languages and what are the differences. So Python is considered as formal, which are strict. Natural could be ambiguous. You can find that syntax is really important for formal languages, and you can find some errors. For example, this one from chemistry is not considered as chemical formula, because it's this one it's not a chemical element. And the same is for Python. You can consider Python as a chemical language in which you have to define a program with the right statements and right terms. Here you have exercise and some differences between formal and natural languages. And let's move on the first program. The first program is programming is Hello World. This is a really popular and famous one, and we can test it here. The idea of this program is to take something as input, in this case hello world, which is a string, and to give it as output to the console. As you can see here we have the output hello world. So this program is taking something as input and it's giving output the same thing here. And here you have two versions, one is with brackets and the other one without. So this is just syntax flavor. Right now in 2018 maybe you can stick to Python 3, which is going to be next standard for Python. And let's move on the other part for practical debugging. So here you can play with this program and to do some special things. For example, test if we have error here, for example print 1, what is going to be output. As you can see here we have error, which is runtime error, and we can have extra or to remove the bracket sign here or the quotation sign. And as you can see here we have errors. Here we have even a syntax error, and as it's written in this chapter, it seems that some people are reacting really bad on computer and computer errors. They get nervous and they start to be angry and embarrassed. So as this book suggests, you can think of your program as a friend or employee, and you're manager of this program, and you need to be friendly and try to understand what is saying this program to you. For example, we can see that we have invalid syntax here, and maybe the problem, I will run it again, maybe the problem is that we don't have these starting symbols for quotation and bracket, and these symbols are symmetric. Usually quotation is symmetric and brackets are symmetric in programming, so you have almost every time error when they are not symmetric, and this is the case here for this program here. So that's all. Finally, you have a glossary, which are some terms related to programming. You can pay attention to them in order to have some basic knowledge or general knowledge about programming. And that's all for the first chapter of Think Python. And if you have any questions, please do share them. I will put all links and all the information required for you to start with this book and PyCharm in the description below. And next time I will do video about chapter variables, expressions and statements. So thank you for watching and see you next time.